Okay, so question 8, part F, part I. Explain the intensities of K, L and M. And what it's saying is, it's saying that you've got an ultrasound emitter. It emits some ultrasound into here. Okay, and what K, L and M are showing you are, K is the amount that's emitted, so it says that there. It says K represents the intensity of the waves that are emitted. So what's happening at each of the different ones? Well, if that's the amount that's emitted, then the first bit of reflection is at the skin, so that's going to be K. The second bit of reflection is L, so that's going to be L. And the third bit of reflection is here, and that's going to be M. Okay, so then we just have to describe the sizes of them and what they are. So K is small because a small amount is reflected from the skin. And you can even say that that means that you know that the change in density is small. Okay. Next up, we've got L is large, so a large amount is reflected from the front of the kidney. And this tells you that the change in density is big. M is smaller than L, even though the change in density is the same. This is because most has already been reflected. Most of the wave already reflected at L. Okay, and what you're looking for there is you're looking for enough marks to be able to give 2 for each one. Okay, so and basically what you're saying is you need to say what it is that has done the reflecting. So the skin has done the reflecting, and you need to say how much, whether it's small or large. So that gets 2. Large amount reflected from where it is, from the front of the kidney. I dropped mark because I didn't say that this was M is smaller than L. Change in density is the same. Because I didn't say that that was reflected from the back of the kidney. Okay. And because I didn't say that, I would have dropped mark, because you're looking for where and how much. So I said smaller, but I didn't say where from, so I needed to add from the back of the kidney. So where and how big it is. So what does that tell you about how much is reflected for each one? Okay, last one. Speed of sound in the body is 1,500. Using the information on figure 3, calculate the maximum width of the kidney. So you know that that is S equals 1,500 meters per second. You know that speed equals distance divided by time. It wants you to know what's the maximum width of the kidney. You know that the width of the kidney is from L to M. You know that the time there is 8 times 10 to the minus 5. So you need to write down T equals 8 times 10 to the minus 5. You need to rearrange this to give you distance. So you're going to say that, so you need to take that t up to the top. So you're going to say that d equals speed times distance, which equals 1,500 times 8 times 10 to the minus 5. And that will give you an answer of 0.06 meters. Now, if you just did oh, sorry, yeah, I forgot to tell you that you need to divide that by 2. Because the time difference, if you look, is this m has had to go there and back again. So that is the distance that it travelled. It's there and back again in this in this 8 times 10 to the minus 5 seconds. So you need to divide this distance here by 2 to give you 0.06. Sorry, I forgot to say that. If you didn't divide it by 2, you lose a mark, and if you so you get 2 marks if you wrote 0.12, and you lose a mark if you when you wrote this out. So say if you wrote out distance equals 1,500 times 8 times 10 to the minus 5, you get 1 mark. If you put 2 there, you get 2 marks. But if you pressed a button wrong on your calculator, you only lose 1 mark for that. So you lose 1 mark for not doing the half. You lose 1 mark for pressing the button wrong on your calculator if you've got the calculation written down. If you don't have the calculation written down, it doesn't matter if you knew it. That's why we've got to write down our calculations.